Assalamualaikum warahmatullahi wabarakatuh, and have a nice day to my fellow lecturer and my friends. I am Nur Dhiyaulhaq bin JAMALLUDIN, and this video is my minor presentation for the Integrated Design Project 1. First of all, before I start, let me introduce my group members. Firstly, we have Hock Sang and Ji Shengzi from the Earthwork Department, and then we have Shakir Ahmed Daniel and Adam Daniel from Erosion and Sedimentation Control Department. We have me and Kelvin Oscar in Water Reticulation Department, and lastly we have Vivian Harry and Lydia Afrina in Cost and Estimation Department. In this video, I will be talking or giving some brief explanation about our project background, and then about what are the things that have been done by other departments such as the Earthwork Department, Erosion and Sedimentation Control Department, and lastly the cost and estimation of the project. So let me start my presentation by giving a brief introduction on what our project is all about. A site located at Mukim Ulu Tridam, Johor was planned to be developed into a light industry with the goal to boost the region's economy and deprive working potential to a used plot of land. Currently, the region consists only of trees. This proposed site has the potential to be expanded as the neighboring plot of land has many housing estates. Not only that, but the proposed site is also accessible due to the surrounding elevation being similar to the proposed site. The area of the proposed project site is about 4,351 meters square. This is the plot of land that is going to be used for the construction site. The first phase of any construction activity in the development of a project started with an earthwork project. Earthwork is an engineering project that involves moving a large amount of soil or rock on the earth's surface. The project includes site clearing, excavation, transport, filling, compaction, and sloping. It is carried out to produce areas of land with certain level for all civil purposes such as housing, businesses, recreation, infrastructure like roads, and so on. The reduced level proposed in this stage will have an impact on the design of road level, sewerage gradient, piping system, and other factors. Existing site inventory and topography surrounding development, facilities, economy, and client expectation all play a role in determining the proposed level of the construction site. Earthwork involves excavating the existing land to a design level before the commencement of any development. The process of earthwork in this project includes excavation, grading, temporary shoring, cut and fill, compaction, and lastly the disposal. The objective of this earthwork are firstly to determine the proposed level of the site, to estimate the volume of cut and fill based on proposed and existing ground level, and then to determine the gradient and stability of slope. The scope of work for earthwork are firstly to determine the proposed level of site, and then cut and fill process by utilizing grid methods within the site boundary, cross-section of the site layout after cut and fill works, gradient and stability of slope analysis by utilizing Bishop's simplified method of slices, typical temporary earth drain, soil erosion, sediment yields, and sediment basin design for surface runoff based on manual Saliran Masla Alam MESMA requirement and specification. So this is the proposed layout for the proposed level of the earthwork project, and also the proposed cut and fill layout made by the earthwork department. In earthwork analysis, the proposed level is determined by considering the existing site topography and surrounding environment features such as road and utilities. From the proposed layout plan, there are 3 entrances for each zone of the plan as they are not interconnected. Entrance 1 and 2 are proposed at existing road junction, while entrance 3 is proposed at the side of the highway where relocation of utilities might be needed. The proposed level for the site is also set by taking into account the highest flood level obtained from Jabatan Pengairan and Saliran JPS, or the level of the nearest existing road level and discharge point. As the overall proposed level for the site is higher than surrounding area, gentle slopes are proposed at the main road at the entrance, while one-to-one slope are proposed for all locations with difference in height. For location with a height difference that is too great, which is 7 meter, for example, two 1-to-1 slopes are proposed on top of the other. For the road, it is proposed to have a gentle gradient based on the proposed level of the surrounding development. And then on the right side, we have the cut and fill layout using the grid method. Cut and fill process is important in designing the proposed layout to reduce cost and duration of the project. Cutting process refers to the excavation of earth at the area where the existing topography exceeds the proposed level. On the other hand, the filling process refers to the embankment of earth at the area where the existing elevation is lower than the design proposed level. In this project, grid method is used to determine the volume of area needed for cut and fill. On this slide, we can see the summary of cut and fill calculation, which has been calculated by Earthwork and Ji Shengze. As the difference between cut and fill volume calculated in the first trial is 11.85%, which is greater than 10%, the proposed level in the southern zone is modified and the second trial on cut and fill volume is done. The percentage difference obtained from the second trial is 4.64%. Other than the cut and fill method, we have another method called the bishop method. The simplified bishop method uses the method of slices to discretize the soil mass and determine the Fs, which is the factor of safety. This method satisfies vertical force equilibrium for each slice and overall moment equilibrium about the center of the circular trial surface. By using the provided equation, factor of safety for a trial failure surface in terms of slope, slide, toe, and deep slip circle can be calculated as the value in the table above. Next, we move on to the next department, which is erosion and sedimentation control. Erosion and sedimentation are natural processes that happens in our world. It mainly happens in the tropical environments such as Malaysia. These processes occur daily on all land, mainly due to deforestation, construction activities exposed to wind, rainfall, and runoff, and uncontrolled land disturbance. The meaning of erosion in the context of soil and watershed conservation is the detachment and movement of soil particles that happen due to natural forces, wind, and primarily water, whereas for sedimentation, it is the build-up of sediment on the land surface or bed of the watercourse. It is the process by which particulate matter is carried from its point of origin by either natural or human enhanced process that are deposited in water bodies or land surfaces. It is natural product of stream erosion that can increase sediment load by human activities and practices. It is very important to have effective control to overcome the impacts of erosion and sedimentation process. There are 8 recommended principles for erosion and sedimentation control, such as the list above. This is the final proposed erosion and sedimentation control design for both zones. In summary, the elevation of our project site in Zone 1 decreases from 75 meter in catchment area A to 37 meter in catchment area C. For Zone 2, the highest elevation is 39.6 meter to the lowest 38 meter, and for the zone, the height decreasing from 53 meter in catchment area F to 36 meter in catchment area E. So we can conclude that the water flow of our project is moving from a high level of the right side to the left side in our proposed area. So what does it mean by runoff management? Runoff management is a way to control any movement, volume, or velocity of the stormwater from damaging the site through erosion. A suitable runoff management PMP will reduce and minimize the potential of erosion on the site. The primary purpose of this management is to direct the stormwater away from exposed soil by constructing transport control. Stormwater runoff is water that flows over land from rainfall that often causes flooding, erosion, and pollution problems. So this runoff management is critical to reducing erosion on site. Runoff management shall be appropriately designed to ensure the facilities can function well on site. One of the fundamental criteria in calculating and designing the temporary drainage and earth basin is estimating rainfall data and the site's ground condition. It is important to ensure the sediment basin and temporary drainage can withstand the highest peak discharge on the site. For the rainfall estimation, it does involve three things that are frequency, duration, and intensity analysis of data. It can be broken into average recurrence interval ARI, time of concentration, and average rainfall intensity. Then a temporary drainage system should be designed, such as the system does not contribute to the sedimentation problem, that is stable channel design, the runoff surface water channel to a sediment basin or silt trap before discharge to the nearest natural water courses, such as a sediment basin or silt trap. For the temporary drainage design, we decided to use the trapezoidal shape, where the depth shall not exceed 1.2 meter and not less than 0.6 meter. In order to ease the construction project, it is recommended to use swales with trapezoidal cross-section. The bottom width should be controlled with between 0.5 meter and 3 meter because the minimum bottom width function allows for construction consideration and provides a minimum filter. For water quality treatment, while the maximum bottom width is it prevents shallow flow from concentrating and potentially erodes the flow channel. And then, apart from the earth drainage, we also have a sediment basin. In short, a sediment basin is a structure usually formed from excavating or building an embankment across a waterway or other suitable location to collect and store the sediment from site clear or during construction for extended period before re-establishing permanent vegetation and building permanent drainage structure. It usually consists of an impoundment, a riser pipe outlet, a dam, and an emergency spillway. The sediment basin works in a larger catchment area where the process is similar to sediment that traps sediment before it leaves the construction site. Lastly, we have the last department in this project, which is the cost and estimation project. This department works about the approximation of the entire cost of a project or operation, comprises site clearance, topsoil extraction, cut work which entails soil excavation and transportation, field work which involves soil spreading and layering, and soil compaction. In summary, estimation is the process of determining the cost of building projects. Will ultimately cost considering all factors including labor, materials, equipment, prices, and taxes. As what you can see in the layout above, we have decided to divide the plan layout into two phases. We divided it by referring to the proposed level and the cut and fill area, with which each phase has approximately the same volume of cut and fill. Phase 1 will start activity since it is a much larger area. For a cost-efficient project, the choice of equipment and machinery are very crucial as it can substantially impact the cost of the whole project. Therefore, for the dozer, we have chosen to use Caterpillar D6G Series 2. For the backhoe, we choose JCB3CX. For the excavator, the Hitachi excavator has been chosen. And then for the compactor, we use Volvo SD110. And lastly, we chose Aumann BJ3523 dump truck to be used in our project. As I've mentioned earlier, this project is divided into two phases. Therefore, the cost and estimation is also divided into two phases and can be seen as in the table above. And then these are the total cost of earthwork equipment and also the cost of operation for this project. In summary, the total cost for the first phase is 5.56 million and for the second phase is about 6.19 million, making a total of about 11.8 million ringgit. One very important aspect in designing the cost and estimation of a project is what we call value engineering. Value engineering is used to solve issues, find and remove unnecessary expenditure, and enhance functionality and quality to guarantee that the client obtains full benefit for all costs of the project. The strategies that can be used to apply this principle is by first reducing the volume of cut and fill, or use another machine with similar capabilities but a lesser cost each day, or instead of expert labor, we use semi-skilled labor. After applying the value engineering knowledge, we managed to save the cost of this project by 40% from 11.76 million to 6.56 million. With that, thank you.